Good morning, Professor and everyone. Today I will present the topic of this week with title Coagulation using organic carbonate open up a sustainable route towards generated terminal film. Let's get started. My presentation divides to four parts. The first introduction, the second the produce of fabricating cellular membranes, third result and discussion, and finally conclusion. Yeah, I move on to introduction. Due to its biodegradability and biocompatibility, cellular its modification and derivatives are intensively used in numerous fields such as textile, packaging, paper production, environment medicine, and separation technologies. In most of these applications, cellular is present in the form of cellular, two so-called regenerated cellular and RC. An important challenging of both industrial and non-industrial processing of cellular is priority solution to obtain RC. Current processes are quite problematic as they involve toxic solvents and reagents and involve several derivatization steps. This article developed a simple fast process at room temperature using non-toxic recyclable water compatible and renewable chemical to produce the AC. And this is produced to make cellular membrane film. Have two steps. The first step is to dissolve the microcrystalline cellular in TBBS 50% in water. TBBS is mean tetra butyl fosforium hydroxide, and to make the microcrystalline cellular dissolve and to make the clear solution is a cellular solution, and have a two treatment. First to coagulation with propylene carbonate. Here is propylene carbonate, and then washing, and then grinding. We get the powder of cellular, and the second testing or second roast is the first is from the cellular solution also casting to casting, and then treatment or put the propylene carbonate into, and then make coagulation, and then washing to create two type of film or cellular membrane. In the left is a transparent film, is also use cold solution is DMSO, and the right is not transparent is film 1, and transparent film is film 2 is also not use DMSO like the cold solution. And after have two rows to synthesize, this is the result and discussion. The first is auto check the powder and the membrane of cellular after synthesize, but no change the structure with the original cellular crystalline, and also to propose the mechanism for precipitation of cellular chicles by propylene carbonate like that. The first Probably the first TBOS, the group of OS in TBBS, tetrabutylfosphorium hydroxide, and to break the hydrogen linkage between the two cellular chain, and make it dissolve in the solution. And then after have a solution to degenerate the cellular, um, attribute the propylene carbonate. Here is a propylene carbonate electrophilic reagent, and OS of TBPH is a uh, nucleophile reagent, and OS of TBPH will attack to propylene carbonate and uh, to remove the OH, and then is the reason the hydrogen linkage between the two chains of selenol to degenerate, and the selenol degenerates selenol to obtain, and it's a mechanism for degenerate of selenol. Uh, to prove for this confirmation, author made some spectroscopy, FTIR, or some other method, analytic method, TDA, and carbon 13 CBM, ASDNB, and in the graphs, FTIR have no change in structure or something from the degenerate serenal is a film 1 and film 2 I explained before, with the crystalline serenal have no change. It means after this zone and degenerate is no change in structure, and is a TDA is a the blue line is a micro crystalline serenal, and the black one is a acid film one with no treatment cold solution DMSO, and film 2 with a DMSO. We can see here is a blue line have lots of more weight than the red line, and black line. It means um, some volatile. The compound is evaporate, and the starting to decomposition or uh, pyrolysis is the same as the same the temperature here and here. Yes, and this is a spectrum of 13 carbon, CBM, ASDNP, and you can see no change in the big, but the carbon 4 have some in the frame, and film 1, RC film 1 and RC film 2 have a C4 have up to the upfill. It means I can explain. It means the film 1, film 2 is have a more free of the carbon 4, and it means the surface the surface area is increased. And this is a surface property of as a film 2, because film 2 is transparent and smoothie, and we can see here A is light microscopy is made of 17 cross section of acid film processed in hand. For electron microscopy section stained with Turin scale is the thickness is 15 micrometer, and this B is the image of 10 microfiber, and we can see it have a ultra structure of acid film here, and C is the same image of same layering. We can see it have a uniform multi-layer same layering, and this is a image of same cross section is a thickness of the membrane here, and uh, about 200 nanometer, and this is E is this is D is 10 micrometer, and the last one is AF image of dry film provides primary roughness, and we can see is roughness is the surface is really smoothy. And after to fabricate the two film 1 and film 2 with two different condition or solvent condition, in this is applied to uh, uh, futures futures water, and we can see with film a acid film 1 and 2 is acid film 1 is black dots or black lines here, and acid film 2 is red line. We can see the first the water flag here is with the film acid film 2. You can see is the maximum is almost 8 liter, and Nisber um, um, Nisber meter minus square, and 8 minus 1 here is in other atmosphere almost 1.2, and the film 1 is the reflux is more than 5, as almost more than 2 par pressure. It means the water flux of film 2 is higher at lower pressure, and the image 2B is the pressure with rest flow this, and we can see the film 1 can tolerate with higher pressure at almost 2.5 pressure is a break at the film break at the 2.5 pressure as the flow rest almost 4.5, but the film 2 is a break at lower pressure almost 0.5, and with the flow rate about 2.5 is lower than film 1, and the C image C is the molecular proposed diameter of the film 1 and film 2 here. And almost is a diameter with the retention is film 1 is bigger than film 2. And al- al- also to survey the as a pH, different pH. pH 3 is the acid condition, in pH 10 is the base condition. And this is a online continuous flow UV spectroscopy for charged dye, and to achievement with absorption of the dye with the membrane to fabricate membrane 1 and membrane 2. You can see here is the picture A, B, C, and D is neutral and negative charge dye with the absorption immediately and equilibrium reaction approach with about 20 to 40 minutes, but the positive charge dice is slow, and to get the equilibrium about more than 16 hours. In conclusion, the two-step producer involves the dissolution of cellulose in TPPS, followed by coagulation triggered by addition of organic carbonates, generate cellulose powder, and film of high quality can be obtained. This methodology is simple, fast, does not require the use of inert gas, can be performed at room temperature, and is environmentally friendly. All the employed chemicals are non-toxic and can be, in principle, obtained by fixation of carbon dioxide, organic carbonates, or recyclable. And the acid frame have a dense layer structure of micro fibrils with a mass of about 10 to 70 nanometer. The acid frame are stable in water and can be stored for several months. A recycle of the membrane can be done easily by another dissolution step in TBBS. This result indicates the great potential of these methodologies for the sustainable preparation and recycling of the several powders, films, and membranes for ultra or microfiltration. Thank you.